Hey everyone, Andrew here. For 2 separate years on April 1st, Reddit launched a web experiment called rplace. The gist of it was pretty simple. It was a grid of pixels that, as a registered user of the site, you could select an individual one and change its color from a given palette, and see updates from everyone else in real time. This led to a sort of community art project, where various subreddits and factions of users generated pixel art images and memes across this canvas, defending their areas or taking over others. So I thought this would be fun to try to recreate the basic functionality behind it using a tech stack I'm familiar with, PHP and JavaScript, in the form of Laravel and Vue frameworks. So that's what I'll be doing in this video. If you'd like to follow along with the source code or check out the finished project for yourself, I've pinned a link to the GitHub repo containing all of the code in the comments below. Alright, let's get started. First off, we need the backend. This will be a way to retrieve and store data from our grid of colors, and we'll need to do that in near real time. For this, we'll be using Laravel, a popular and solid PHP framework. So let's set up a new Laravel application. In our project directory, composer create project, Laravel, and the current directory. Alright, this installed, and let's open it up. If we go ahead and take a look at the default routes web file, get rid of this here, it's returning this welcome view. But if we open that up, it contains a lot of boilerplate that I really don't need right now. So instead, let's get rid of most of this. We'll rename the title, and get rid of everything in the body tags right now. Instead, we'll just put an h1 tag that says hello world, and leave it as this for now. We'll also go ahead and rename this file just index.blade.php, and reference index instead of welcome. While we're developing, we can serve this application locally to see what we're doing. In the terminal, sudo php artisan serve, and I'm going to specify the port as 80 so that I can use a localhost domain name. Now if we navigate in the browser, we can see the hello world that we added into our view before. Before we go any further, our backend should have a way for users to authenticate themselves, to register for accounts and sign in. Because rplace tracked which pixels on the grid were changed by specific users, our app should too. And Laravel has a first-party package called Breeze that provides some boilerplate authentication that we can get set up quickly. Let's go ahead and follow the installation directions. In the terminal, composer require Laravel Breeze, dev, and then PHP artisan, Breeze install. Alright, so this is all done. Now we only want registered users to be able to access our app though, so in our routes web file, we'll add a guard on our main route, meaning that only authenticated users can view it. So let's get rid of these comments here, and we add routes group, middleware auth, and a closure function that contains the routes that we want put underneath this middleware. In that case, it's just our main route here, and we can get rid of this dashboard route provided by the Breeze boilerplate, since we won't be using that. We also want to make sure that after a user registers or signs in, they're redirected to the main application instead of the default, which is a dashboard route that we just got rid of. So let's open up our route service provider file, and in this const home, instead of dashboard, we're just going to use the root path. So now if we go back to our browser and refresh, we're redirected to the login screen. But we don't have a link for our user to register for an account if they don't have one. So I'm going to go ahead and add that in. We have a bunch of view files given to us by Breeze, and I'll make use of them. So in the components, we have this auth card component here, and I'll just add a new element underneath the white box that we have already. And we'll call it a bottom slot. So now in the login blade template, we can call x slot name equals bottom, and put a link to the registration route. Alright, now we can click our sign up link and be brought to the registration page. Let's register for an account. And we're brought back to our main app's view, exactly what we expected. Okay, so now that we have authentication set up, we have to think of a way to store and retrieve color data for our future pixel grid. We could use the MySQL database that this application is already attached to, but that wouldn't be optimal considering just a 1000 by 1000 grid is a million individual rows. Instead, I'm going to use something a bit more suited toward large amounts of data, Redis. Redis acts like a key value store, so we can just reference an XY coordinate as the key and our color as the value. It's also lightweight, incredibly fast, and can be used out of the box with Laravel. I'm just going to spin up a quick Redis instance on my local environment using Docker, and then connect it to our application through Laravel's .env file. The host password and port will remain the same, but I need to add a few other attributes. The database will be 0, the client we want to use is Redis, and Redis prefix is an empty string. So now that we have a place for our pixel data, we need to create a way to generate the initial set for our grid. Using Laravel, we can create commands that can be run in a terminal, and that seems like a great way to get our pixel data seeded. Let's go ahead and create a new command using PHP artisan, make command, and we'll call it seed pixels. Opening up the file, we can change the description as well as the signature or how we call the command in our terminal. We'll change the signature to pixels seed, and for the description, seeds the Redis database with random pixel data. And down here in the handle method is where we'll add on our functionality. Now thinking about this, I want to keep our app pretty simple. So I think we'll just have a grid starting out with 10,000 pixels or 100 rows by 100 columns. And based on how I said that we should store the data previously, we'll need 2 nested for loops. The first one going from 0 to 99. And then the second one also going from 0 to 99. So now in each iteration of this inner loop, a set of X and Y coordinates are available that we can use to set a pixel in our Redis database. We can do that by calling Redis set, providing the key, which in our case is the X and Y coordinates, separated by a colon, and then the value that we want to store at that key. Now instead of storing the actual color, I said in the beginning there's only a select few to choose from in a palette. Instead, we can just store an index of the color and reference it when we build out the front end. I'm thinking we'll stick with 8 different colors, which means an index between 0 and 7 is what we can use for the value here. And at the end of this, we can return back 0 to ensure that the command exits successfully. Alright, now let's open up our terminal and run it. PHP artisan, pixels, seed. Oh, I almost forgot one step, and we have to install the Redis client into our application. Composer require, Redis, and now that that's finished up, we can try our command one more time. It finished up, but now we need a way to retrieve this data and view it ourselves, as well as provide a way for our front end to grab it later on. Let's create a new route. And we'll call it map. Now unfortunately, there's no method to just get all of the keys and values in a database. Instead we have to loop through them one by one. So first we'll create an empty array of Redis values. We'll just call that pixels, and then let's replicate our nested for loop that we used to create X and Y key values. And then instead of set, we will use get, add that to the array of Redis values, the pixels, and then lastly return the full array. Now this works, but the problem with it is that it's pretty slow, but there's a way to optimize it. We can instead pass in an array of keys to Redis and get back an array of values instead of just one at a time like we're doing here. So instead, in this first for loop, we'll create a placeholder array called rows, and then we will remove this Redis get call here, and instead add on to the rows array the X and Y value. And then we will add on to the pixels array using Redis, but instead of get, we will be using mget, which takes in an array, in this case our rows, and then returns back an array of values that match the keys that were found in this array. This should cut down our execution time dramatically, as we're only doing 100 gets instead of 10,000. Now if we head to our browser and go to this map route, we can see that we now have a multi-dimensional array of our grid data separated by columns and then rows in that column, each one containing our color index value. Remember earlier I said we'll also be keeping track of the user who changed the pixel last? Well, that data should also be present in this value, so let's go back to our application source code. First, we'll have to create some fake users. Using Laravel's database seeder class, in the run method we can call the user model, and the factory method, passing in the amount of users that we want to create. In our case, let's do 50, and then tacking on this create method afterwards, we'll create each one of those models and save them to the MySQL database that's attached to our app. Now if we open up our Redis seeder command again, we can adjust the value that we have here instead of just 0 to 7, and we want to include a random user's email address as the last person who changed the pixel. So for that, first let's get an array of all of the user's email addresses. So we'll call user emails is user, pluck, email, and to an array. So we will get a flat array of just emails from this user table. And then for the value, we will add a colon after this, and then followed by array random, a random value from our user emails array. So now let's head back to our terminal. And first we're going to generate those random users by calling PHP artisan, dbseed. So now in our database, we should have 50 more random users. And then we can reseed our pixel data by calling PHP artisan pixel seed. Okay, heading back into the browser, let's see if this worked. And it did. So for our data, instead of just having 0 to 7 for the colors picked on the pixels, we also have a colon and a email address associated with what is supposed to be the user who changed that pixel last. Now we can work on the front end and make use of the data that we're getting. For our front end, we'll be using a mixture of this blade template that we had created earlier and Vue. It's easy to set up and use and takes a lot of the headache out of the interactivity that'll come with this app's front end. Let's install Vue 3 and get it set up with the build environment. So in the terminal, we can just run npm install, save dev, vue at next. And Laravel now uses Vite for the build step, so that's what you're seeing here. We have to add a Vue Vite package. Back in the terminal, npm install, save dev, and this Vite.js plugin Vue. And we'll have to adjust this configuration a little bit to use Vue with it. So we'll need to import Vue from the Vue plugin that we had just installed from Vite.js, and then we use that here. Template, transform asset URLs, base null, and include absolute is false. Now we should be good to use Vue code and build it with Vite. Opening up our main app.js file, let's import the create app method from Vue, as well as an app component that we will be creating here shortly. So in our JS folder, we'll create a new file under components and app.vue. And we'll save that for later. Next, we just call the create app method, passing in our app component and mounting it to a element with the ID of app. And let's go ahead and add that component to our index blade file. So instead of this hello world that we have here, we'll just create a new div with the ID of app. Now let's go to our app.vue file and initialize it with a quick template and a setup script. We'll add in a basic wrapper here and just have it kind of echo out a message. And we'll say hello Vue. This way we can determine if Vue is working when we go and load up our front end again. Also, this is using the newer composition API style of writing Vue components, but you can still use the options API if you'd like. For more info on the difference between the two and how to get started with the composition API, I'll link an article that I've written in the description. So now let's go ahead and build our assets. In the terminal, npm run build. And we have to make sure they're added to our blade template. So right now we don't have a script file added in here, @vite resources js app.js. And now let's check out our browser again. So as expected, we have a hello Vue message here, which means that Vue is loaded in and working as expected. The next thing we need to work on is getting an area set up to start drawing out our pixel grid. And instead of using individual elements for each of the pixels in our grid, we're going to use a single canvas HTML element and then use JavaScript to actually draw out the graphics. In our main app.vue file, let's go ahead and create a canvas element. And we'll give it a width and height based on the amount of pixels in our grid. So that's 100 by 100. We'll also add in a ref attribute here called place that we'll use later on to reference this canvas in our Vue script. We need to pull in our map data so that we know where and what to populate. So let's go ahead and do that first. Let's get rid of this message here. And we can use the onMounted lifecycle method, which takes in an anonymous function as the hook. So inside here, we want to grab our data that we had on the map route and use it later on to populate our canvas. So we will fetch map, and we'll need to add some headers in here, content type, and accepts both as application JSON so that we get back the intended format that we expect from Laravel. Then we get back a response, convert that to JSON, which then gives us back our actual data that we saw earlier in the map route in our browser. So that is the nested arrays, each one containing a column, and then each one of those containing rows of data. So here's where we actually draw the pixels onto the canvas. And in order to do that, first we have to get the context of the canvas. So that is place value, get context as 2D. Now you might be thinking, wait, hold on, where is this place coming from? Well, that is the ref that we added up here as place. In order to actually use that though, first we have to import ref from the Vue package and initialize it with a constant of place is a null ref, but then this will automatically be filled in with the reference up here that matches the same name as this constant. So the place that we reference here is the same as this element. And then the value is the intermediary that gets us the actual element itself. So we have the context of the canvas, and then let's loop through our data. So data for each, this gets us a column and then an X value as our current index in this for each loop. We have to do that one more time though, and go through the row. So in the row for each of these items, it's a pixel, and the index for that is the Y value. So now in here is where we draw each individual pixel. Now remember, for the value that we have for this pixel, it is a color index, then a colon, and then an email address. So to utilize those, we'll split them apart. So we will let color index and an email address equal pixel split at the colon. And then we can call the context fill rect, which will create a rectangle at a certain X and Y value that we give. So for that, we just use the X and Y values that we have through these for each loops. And now we need the size in width and height. Well, that's just 1 pixel each. We have a 1 pixel square being drawn at the X and Y coordinates. Right now though, it's colorless. If we were to refresh this, it would be a grid of white squares. We need to determine what color is being filled into them though. And for that, we set CTX fill style. We're going to use an RBG value, but we need to know what that value is. Now before, we had talked about the fact that this color index is going to represent an index of 0 to 7 based on an array of predetermined colors. And so for those, I have an option of 8 different colors that I will just go ahead and paste up in here as its own object. All right, so here are our 8 options. And I'm adding these in as an object because I'll be referencing these key names later on. In order to pull them out by the index number though, I'm also going to add in this function here that takes a number and then spits back out one of these color options based on the known position. So we'll just return this, object keys, this, and the number given. Okay, so now down here, our fill style is RGB, and then plus, color options, key as the color index, and then end the RGB. So now let's refresh our browser and see if this works. Okay, well, it is something. It looks messy and kind of blurry, but we can see that we have 100 by 100 pixels, and they are all random colors based on the color options that we have. The biggest problem though is that this is pretty tiny. I don't think most users would be able to select an individual pixel on this to change its color. Instead, let's zoom it in. So going back to our component, let's use a style tag at the bottom, and we'll style the canvas to be transformed to 16 times its normal scale. I also need to add in some additional attributes like image rendering and transform origin as top left. This way it's scaled up from the top left down to the bottom right, and the image rendering pixelated will make sure that the individual pixels are nice and sharp squares instead of being blurred together. Alright, so here is what we have on our browser now. A much easier to select pixel grid. And unlike the real RPlace, for this example, I'm going to keep it at this zoom level for the rest of the video. The whole basis of RPlace is that a user needs to be able to pick out a pixel and change its color. So first we need to make this grid more interactive. Let's add a click handler to the canvas element and set it to a method that we'll create. Now once it's clicked on, we need to record the pixel that was chosen and store it as a data value in this Vue component. So first let's get the X coordinate that was clicked. So clicked X is ePageX, and clicked Y is ePageY. And so toward the top of our component, let's add another element here, another variable, and we will call it active pixel. And it's a ref that is currently null as well. Down here, we will set the active pixel's value to the clicked X value plus the clicked Y value separated by a colon. And this keeps it in line with the Redis database so we can reference that key value later on. But there's a problem. Because we are scaled in to 16 times the normal size here, the X and Y values that we're using for the part that's clicked on have to actually be adjusted. So instead of just the page X, it needs to be page X divided by 16. So we'll use math floor to get a rounded down value and divide that value by 16. Same with the page Y. Now we need a way to display this to the user and show what pixel they have selected, because otherwise they're not going to know which one is active just because it's been recorded in this method here. We need visual feedback. So let's create a new element in the template and we'll call it overlay. And this is conditionally displayed if there is an active pixel. We're also going to give it a dynamic style set to a variable overlay style, and I'll explain why shortly. We'll start off that style though with some defaults. So overlay style is reactive, an object that has a top of 0px and left of 0 pixels. Back down into our canvas clicked method here, let's go ahead and change that overlay style and set the top to the clicked Y position times 16 and the left to the clicked X position times 16 as well. And both of these are in pixel values. So what we are doing here is that by default, the overlay style is set into the top right corner. I'll show you on the browser. It's set into this top right corner here and is invisible. But when a pixel is clicked on, what will happen is that it'll adjust the top and left position to the nearest top left corner of the pixel that was clicked on, because we're timesing it by 16, which allows it to snap into one of these individual pixels. And before we see what this looks like in the browser, I have to add some additional styles to the overlay element so that it's more easily visible. Position is absolute, and we'll set the z-index to 99 so it's always on top. The width is 14 pixels as well as the height. So it's a little smaller than the individual pixels at 16. And we'll set an inside border of black. Lastly, we'll set a box shadow so that it has some kind of highlight to it and gives it almost a glow appearance. So let's go ahead and see what this looks like. Okay, so if we click one of these pixels, well, the overlay is showing, but it's not exactly showing where we want it to or expect it to. I think the issue is that our body margins are still set to the default. Let's go ahead and change that out. So body margin of 0. And trying this again. And there's still something else that's blocking us. Oh, I have this empty H1 element here still. Let's get rid of that. Okay, refreshing and clicking around. Our little overlay is highlighting the pixel that we are clicking on. So perfect. Now we also need something to let our user pick what color they'll change this selected pixel to, a sort of basic palette, as well as show what user's email last changed that pixel. Going back to our source code, under the overlay element we just added, let's add in another one. This will have an ID of color picker, and again will only show if there's an active pixel. And then in here we will just display the last changed by email address. And we'll have that set to a variable called active pixel email. And I'll generate that in a little bit. We also need to display the palette of colors to choose from, and we will use a for loop on some buttons. So v4 color in object keys, color options. So now for each color in this color options object here, this will be the keys that we get back. We'll set the key to the color because those are unique values. The class as well to the color so that we can style each one individually. And when they're clicked, we will call a method, and we'll call it change pixel to the color that is in the loop right now. All right, so we have a few things to add here. Active pixel email and a change pixel method. So let's add the change pixel method down here. There we go. And the active pixel email is going to be a computed property because we want the email address of the current active pixel. In order to create a computed property, we need to create a new constant, active pixel email, that matches the name, and it is equal to a computed property, which takes in an anonymous function and returns a value back that is updated as the item updates. So if there is no active pixel, we want to just return a blank string. But now we need to figure out how to isolate the email address and provide it to this element. What I'm going to do is I'm going to grab the X and Y coordinates from the active pixel. So it's active pixel value split down the colon. And then I'm going to return back, if we go up here, this data that we're getting back here is a nested array consisting of indexes that represent the X and Y coordinates, because that's how we have parsed this whole chunk out. If I was to save this whole data chunk into the Vue component here, we could then just reference a spot in the array by using these X and Y coordinates. So first, let's go ahead and create that attribute up here. Above the place constant, we'll call a constant map, and it is a ref that starts out as an empty array. And then if we go down here, when we get the data back, we'll set map.value as the data we're getting back. So then scrolling back down to our active pixel email, we can then get the email address out of that whole map array by returning map.value at the X and Y positions and splitting the colon apart, which gives us an array consisting of 2 items, the color index as the first item and the email address as the second. So we're looking for the 1 position. Okay, so now that that's finished up, let's go ahead and add some more styles down here, and we'll style that color picker area that we just created. Okay, so we're setting it to the bottom as a fixed position, background of white. We set some styles for the text and the buttons. Instead of doing each individual button though as a class with a background, I should be able to reference our color options here and set the background dynamically in the for each that we have for it. So let me just reposition some of these attributes in the button so that it's easier to look at. And let's set a style attribute as background. And we will set that to RGB plus color options color plus close out the RGB and close out the object. Okay, so back in our browser, let's click a pixel. All right, so we have our pixel being selected here, our last change by email address here, and we have our buttons down here, except we have this extra button at the end. Oh, I know why. So that's because we're doing a v4 here in object keys, and we are referencing this key function that we had added on here. So maybe we shouldn't be including this in the whole object. So instead what I'm going to do is remove that. And where was I using it? Okay, instead of color options key, we will fill it in with color options, object keys, color options, color index, and close that out. So now we should have the same functionality, but without this added item in the color options object. Okay, much better. So everything is still working as expected, and we don't have that final button here at the bottom. Now we actually need functionality though to change the color, because right now, if we click on a white square, nothing changes when we click on any of these buttons down here. If we go down to the method that we created earlier for the color button click events, this change pixel, let's get the context of the canvas. And set the fill color as the color that was selected from the button that was clicked. So RGB plus color options, color, and close out of the RGB. Then we'll fill it in using the active pixels value. Again, split at the colon and reference it with the CTX fill style at the X and Y coordinates, filling in 1 pixel. So now we can fill in the pixel that we selected at the specified area that was clicked on. So we click this pixel here and nothing's happening. Oh, that's because I did fill style here. This should be fill rect. Whoops. So clicking on a pixel, and we can update the color to the entire selection that we have down here. But this only updates the color of the pixel client side. If we refresh, it's gone. We need to be able to save the value in the Redis database, otherwise our changes disappear. So let's add in a fetch. And we'll tie it to an endpoint that we'll create shortly, save, and we'll add in some options. So the method is a post. We'll set the same headers that we did in the call earlier. And then for the body that we're posting, it is a JSON object. And we will include the key, which is our active pixel value, as well as the color that was selected to change. In order to get that, we first have to get an array of the keys in that color options object. So object keys, color options, and then we can use index of, passing in the color that was selected to get the index in that array, which will give us our color index. And the way that this application is working we really don't need to do anything with any response that we get back from the server. So I don't need to wait for this fetch to finish up and then retrieve data back from it. I can just leave it like this and let it fire off asynchronously. Let's go back into our app's routes web file, and we will add in the save route that we had just referenced. So below our map, let's create a new route post, save, and it has a request argument that we will be using. And all we really need to do is save the updated color index into the Redis database at the points that were provided to us. So using the Redis facade, set, request key, request color. Oh, but remember, we are also including the user's email address separated by a colon, not just the color index. So we'll have to include that as well. And we can just reference that because this user is authenticated. On the request object, we can call the user method, which gets back our authenticated user model from the database. And on that, we can just tack on the email property and get back their email. Just in case we need to reference this later on, we'll be nice and return a response back consisting of JSON that just includes the Redis property at the requested key. Let me just update this full path here real quick. I don't like that all being in the method property or method parameters. Now we can just call requests, and okay, let's see this in action. So refreshing the page, I'll choose to update this pixel right here to red. Now if I go ahead and refresh, the red pixel should remain there. Okay, but it didn't. For some reason, we are not seeing that update. Let's open up my console and see what's happening. So change to red, we're getting back a 419. And if we take a look at the preview, page expired. Okay, so it's because this route that we're posting to is secured under CSRF protection, but we're not passing that CSRF token through the route. I really don't want to include it for this example, but instead we can just bypass that by going to the verify CSRF token class, and in this accept array, we can just add in our save route. So now going back and refreshing one more time, let's try to change that pixel again. Change to red, refresh, and it is still red. But the whole point of our place was a collaborative real-time effort. And if we have to refresh the page if we wanted to see other contributions to the grid, well, it kind of defeats that purpose. And this is where WebSockets comes in. With this, we can essentially open an active communication session between our frontend and backend, allowing for real-time updates. In order to fully do this though, we'll need to add a few things to both the frontend and backend, starting with the latter. So in our backend, let's create a Laravel event that will fire off whenever someone changes a pixel color. Using the terminal, we can create a new event, PHP artisan, make event, and we'll call it color changed. Now let's go ahead and open up that class. And this only needs a few additions. So first, this should implement should broadcast, because this will be eventually broadcasted out, and we'll talk about that shortly. And then we'll need to pass an array through this event that will be used by every other subscribing application. So public array property, and we'll just call that change. It will broadcast out the change that happens on the canvas, so an updated pixel. In the constructor for that, we can pass in the array, and then initialize it. This change is equal to change. If we take a look at this broadcast on method, this describes the channel that the event will be broadcasted on, which we'll use later on in the front end. Right now it's returning a private channel, but the events broadcasted will be available to anyone who's on the site currently. So we'll change that instead to a public channel. And we can do that by getting rid of this line here and saying return new, just channel. And we'll name it something in line with this event. We'll just call it changes. So the color change event broadcasts on the changes channel. Now back in our routes web file, we need to dispatch this event in our save method. So if we go down to our save route, before we return the response, we can call the class color change, and then the dispatch method, which will include the array of items that we are passing through as the changes. That's the key and the color. It was request color plus a colon plus request user email. And let me just add this to the top. That way we can just use color changed. So now our event is dispatched after the Redis key is updated with the new value. So the event itself is done, but in order to actually use it with WebSockets, we'll need to install a third-party package called Laravel WebSockets. Taking a look back in our terminal, all we have to do is require it with Composer. It's at Beyond Code Laravel WebSockets. And once this finishes up, we can publish the migration file and run any migrations. And we are all set with the installation. If we go back into our code base and open up the env file, we will need to make some slight adjustments if we scroll down to this pusher section here. Even though the pusher app isn't actually used in this instance, Laravel WebSockets uses these values in the package locally, and they need to be filled in. For the app ID, we'll just use Laraplace. For the key, we'll use secret. Same with the secret. And for the host, we can just set as the app URL. So now that we have our backend complete and sending out WebSockets compatible events, we need a way on the front end to listen to them and react to their changes. Back in the terminal, we'll install the Laravel Echo library, which works out of the box with Laravel's event system. Back in the app view file, after we've fetched the map endpoint up here, so we've gotten the data back, we can get Echo configured and listening. First, let's import it at the top of our file. Import Echo from Laravel Echo. And then scrolling down in our onMounted method here, underneath the fetch call for the map, we can create a new Echo object, new Echo, and pass in an options object, which consists of a broadcaster as the pusher library. The key is import meta env vite pusher app key cluster. Similar, import meta env vite pusher app cluster. WS host, the WebSockets host is the window location host name. The WebSockets port is 6001. We are testing this locally and not under HTTPS, so force TLS is set to false. I'm also going to enable this disable stats attribute here so that we don't have any stats showing up in the console log. And then enabled transports is set to an array of both WebSockets and WebSocket secure. So now that we have Echo configured as an object, we can use it to listen on channels and specific events. So we can just call Echo channel and pass in a channel name to start listening to. For us, that was the one that we set in broadcast on in our event earlier, changes. And then we listen to a specific event. Using Laravel's events and the Laravel WebSockets package, that name is just the class of the event that is being called. So for us, that's color change. And then we get back an anonymous function that has an event as the sole parameter, which contains the public properties that we had passed into it, which was an array called change. So we'll get a change property on this event object. Well, what do we want to do with it? We want to update the map the same way that we do if a user clicks on one of those colored buttons. So first, let's get the context of the map. So it's place value, get context, 2D, and we'll get the color index as well as the email from the event change object and the color associated with it, which we split into or by the colon. So now we can set the fill style of that new pixel that we're going to be writing as RGB. And then what did we use up here when we click a button? Or sorry, it was down here. Color options, color. So let's take that and we'll paste that in here. But remember, we can't just call color on this because what we're actually getting back is a color index. So instead we have to do is we have to call color options, object keys, color options, and then the color index of that array. And then we can close out the RGB, which is what we are setting the fill style to. Next, we have to get the X and Y coordinates for the pixel that we're filling in. And that is again in the change object in the event. And that is the key split by the colon character again. So now we can fill that rectangle. Context fill rect, X and Y, 1 pixel and 1 pixel. And then we will, at the end of this, we will update our maps value at the X and Y coordinate with what we've gotten back, which is the new color index and the new email. So this way we can see the updated email when a pixel is clicked on as well. And it'll just keep changes in the current state that we have in this component. All right, the only thing that's left to do is start up the WebSockets server in the terminal, PHP artisan, WebSockets serve. And we can head to our browser and check it out. So if we click around, we can still see the last change by email down here. And let's update a few of these pixels. So far it's looking good in updating our map. But we don't know if it's happening in real time yet because it's just my window that is currently open. So let's open up a second one and see if we can see this happen in real time. All right, and we are not seeing any updated pixels. I wonder if the console has anything to tell us. Pusher is not defined. Oh, okay. I forgot that we need another library in order to use Laravel Echo as a pusher replacement. So back in our terminal, npm install save dev pusher.js. We will also need to import pusher from pusher.js. Okay, one more time, let's start up the WebSockets server, PHP artisan, WebSockets serve, and head back to our two browsers. Okay, so now if we try this again, we are still not seeing anything update. And checking the console, we have no errors. And checking the WebSockets log, we're seeing that we have clients attaching to the WebSockets server, but the events aren't passing through. Oh, okay. I left one more thing out. In the env file, if we go up toward the top, we have this broadcast driver that is currently being set to log. This needs to be set to pusher, which is what Laravel WebSockets is a drop-in replacement for. So now this should work. Let's try this one more time. We'll restart the WebSockets server. Okay, now let's go ahead and try to update this pixel. And we're seeing it happen in our other browser in real time. So this is exactly what we expect. And if we click on a pixel, let's say this one here, we see the email address is currently marcus06@example.net. But if I was to click over here on this screen and update it to my color that I want, we can see that the email address is also immediately updated to the andrew@test.com email, my authenticated user, on this screen. And there we go. Without having to refresh, we are seeing changes in one grid affecting the grid in the other. Our users can now collaboratively draw some fun shapes in this 100 by 100 pixel canvas, and we got it up and running super fast with some PHP, JavaScript, and a couple of awesome frameworks. We've utilized Vue and a canvas element to display this interactive grid and react to user interactions, and we are powering the backend with a Laravel API, Redis database, and WebSockets for real-time event handling. So where can we go from here? Well, if you wanted to make this more like a true rplace clone, you could make the canvas zoomable and more easy for people to navigate. You could also add more pixels to the grid and see how performance is affected and if you can mitigate any problems with scale. Or you can even record the history of the canvas or individual pixels and see which areas have changed over time. I hope you enjoyed watching me recreate this experiment. Let me know if you liked seeing this video, or if you have any ideas for other sites or applications you'd like to see me try and recreate. As always, if you have any questions about this or any other web development topics, please feel free to reach out to me on Twitter or in the comments below. Thanks for watching.